first thing we need to do is write a balanced chemical equation. It tells us that magnesium reacts with hydrochloric acid. Hydroic is when there's just an element with the hydrogen. And it tells us it makes hydrogen gas, which we know is diatomic, plus magnesium chloride. We need to look at the charges on this ionic formula in order to get the correct formula. It's neutral. Then we're going to balance it like so, and then we'll put our amounts on here. We have 1.50 grams of magnesium, excess hydrogen, and we're interested in how many liters of hydrogen gas are made. Well, first we know we can do some stoichiometry to get from the amount of reactant to the amount of product. And we're going to go to just moles because P equals nRT has moles in it. So our first step is just the stoichiometry. This step is a molar mass step. And this is just using the coefficients. And it is, so I'm talking about these numbers right here. This is a 1 and this is a 1. So that's a 1-to-1 on the coefficients. And then we get our number of moles. Like I said, there's no reason to go to grams because gas laws use moles. And this really only has 3 sig figs, but I'm going to write down a few extra since I have a lot of steps. Okay, so this is moles of hydrogen. Okay, then we may say, well, to go from moles of hydrogen to volume, which is what we're looking for, we can just use this. The thing is, though, if I put in this, if I put in the moles of hydrogen, I also have to put in the pressure for hydrogen only, the partial pressure for hydrogen only. Otherwise, I would need the moles of both hydrogen and water. Remember that when you collect a gas over water, it gets water in it. So before I can use that, I need to figure out what this partial pressure of hydrogen is. So to do that, I use Dalton's law. And this partial pressure due to water is the vapor pressure of water. And that is temperature dependent. And luckily it was given to us as 23.8 millimeters of mercury. And that will be given. Sometimes you have to look it up in a table. Okay, so in other words, my total pressure, let's look at where I'm getting this. If I'm collecting it at this pressure, that's my total. So when I plug in here, so just subtracting, that's my partial pressure of hydrogen. And then we might know that we're going to need that in atmospheres instead of millimeters of mercury. So I'm going to divide by 760. On our sig figs, This does have 4 here, so this really only has 4. So I'll just mark it like that. Okay, so now we have our partial pressure due to hydrogen, which is what we're looking for here. So let's do our part 3 over here because I don't have room. Let's see. So this is my third step. Then I'm going to plug into this. Okay, so note that when we get this volume, the volume isn't really just for hydrogen or just for the water. The volume of hydrogen is equal to the volume of the mixture because they're occupying the same space. Both of those gases, here's hydrogen, here are my water molecules, they're all in the same space. So the volume of one is equal to the volume of the other.